Hello everybody, welcome today. My dear student in grade 4, we are going to start our lesson today about what are states of matter and what water. As you know guys, we are now in unit 7, lesson 4. States of matter, as you know before, it's what? Solid or liquid or gases, right? Yeah. States of matter, solids mean like, for example, the table or a chair. All of these solid substance differ from the water, differ from the oil, right? So there is a difference between the three states of matter. First one is the solid states. Solid states, which formed of particles close to each other, or there is no distance or large distance between them. Yeah, it's difficult for you, for example, to break, for example, a piece of iron, right? But you can move your hand in the water during the swimming, but inside the iron you can't, of course. Why? Because there is spaces between the molecules of water, so you can move your hand inside. But the iron you can't, of course, to move your hand inside due to the attraction force between the molecules of iron particles. Understand? So we have here three states of matter. We can start now this session with seeing these videos with each other. Yes. To differentiate between these three states of matter, we have, this is video start to differentiate between three states. Yeah, first part, for example, this is a cube, solid cube. Can you see the particles of the solid? The spaces between them is very small between them, and as the distance decreases between the molecules, the attraction force, of course, between more strong, right? Yeah, so the difference between this molecule and this very small distance, very strong attraction force between them, of course. So it's difficult to break it into two different parts, or its shape, of course, not to change it easily. Yes, this shape or this stick, for example, not change it in its shape, put it in any place, but the shape of the water differ from its shape in the bottle, differ from its shape in the glass, differ from the plate, differ from container to another. But here, the molecules attract each other, so it has a definite shape or fixed shape. Yes? So you have three states of matter, which are solid, liquid, and gases. Here, the distance between the particles of the solid, very small, of course. Yes? Very strong attraction force between them. Here, space is more free. Yeah, more weak. Particles more free, so the space is large, here very large. As you spray perfume in the room, of course, all of us will smell it, right? Why? Because the spaces between them is large, each molecule move away from each other, so no force attraction or attraction force between them. Understand? So start with the solid state of the matter. Here, this cube of solid substance, solidified substance here, if you put it or pour it, what's happened to it? Now the molecules don't be separated from each other or move away from each other, but still fixed and attract to each other, right? Because solid particles are fixed, attract to each other, as we said, spaces nearly not found or very, very small spaces between the molecules. As you know that the solid, it's difficult to compress the solid. It's difficult for me to compress it, right, to a smaller part, yes, but you can compress balloon of air, you can compress it to be smaller to a limit size, understand? But the solid, of course, fixed, strong attraction force between them, so it's difficult to compress it or decrease their size, right? Yeah. So the fluid or solid state, yes, you can't compress it. Here, second state of the matter, which is liquid, yes, yeah, the shape changes, differ from the solid one, not changing the shape, poured as it is, right? Yes. So here the shape change. Why? Because the force between them what is weak. Yes. More spaces between them, so it's easy for them to move and separated from each other like this. For example, this is the water, and the first state for the water, which is solid, as you know, is ice. Yeah? You can compress it slightly due to the spaces between them. So it can compress. Understand? Okay? So this is the liquid state. Now we are with the gaseous state, which is the last state of the matter, not definite volume. Yes? It's a volume. If you compress it, the volume of the size decrease. Yes? The size may increase. Understand? According to the size, so the size can be changed according to compressed or not. So it's not definite volume for it. Okay? Of course, the shape, if you blow, for example, for a long balloon, the same air in the sphere balloon differ in the shape. It takes the sphere shape. In the long balloon, it takes the long shape. Understand? So the shape of gas and the liquid changes, not fixed, according to the container that it's put in. Okay? So this is the gas state, more spaces between them, weak attraction force between them. Yes, like the perfume, every part move away. The particles separate from the other. No attraction between them. If you compress it in a smaller volume, yes, they can be compressed. Yeah? So the volume of gas state is what? Yes, not definite volume and not definite shape. But definite shape and definite volume, of course, is a solid, like the ice, like the iron, like, for example, what? Yes, the wood, yes. All things fixed shape and fixed volume, like the volume of the table, not increase or decrease in the volume, of course. So it's a definite volume, definite shape, so it's a solid. But not definite shape, not definite volume, of course, this is a gas. Okay? But liquid, definite in the volume. If you have 1 liter of water, it's still 1 liter of water, right? But differ in shape, the shape of water, as we said. In the bottle, differ from the glass, differ from according to the container you put it. Okay? So we return back again to our lesson. Yes. So we said that the solid has a definite volume and definite, yes, definite volume and definite shape. Okay? This is the solid state, like the ice, for example, like pencil, like the book, chair, all are solids. Understand? Yes, liquid state, definite volume and indefinite or not definite shape. As we said, the shape differs from container to another. Like any liquid, like the water, like shampoo, like fruit juice, all of these are liquid. Take the shape of the container and not definite shape. Third state is the gas. Third state is the gas. Expand, can be expand, increase the volume or decrease the volume according to its container, can be compressed as you watch the video. Gas doesn't have a definite volume. Of course, we can compress it, smaller size or shape. Yes. Air is an example of gas. And component of air, as you know, that it's a mixture of different gases, which are oxygen, nitrogen, hydrogen, water vapor. All of these are gas states or components of the air. What is the water's solid state? Solid state of the water is ice, definite shape and definite volume. Particles of solid hydrogen, as you watch the video. As you watch the video, that's close together, moving, but stay in the same spot or the same point. Not free moving like gases, for example, or like the liquid. Yes, liquid, like water state in liquid state as you drink it, yes, has a definite volume and not definite shape. The shape according to its container, as you know. Liquid particles further away from each other, move more free than the solid one. And the gas, water vapor gas state is water vapor, is a gaseous state of the water. When you heat the water and boil it, as you know, it will be water vapor gas state. Yes, you give what? You give more energy for the particles of the water, right? So, movement increase, it changes from liquid, the attraction force decrease, more free and move away in the form of gases, right? Particles in a gas are far apart, yeah, the force is weak, farther in all directions. This is the difference between these three states of the matter solid, close to each other. Water or liquid move more free, and here can you see the speed more and more. Very high speed. Sorry. So solid movement in its spot or its point. Here the movement more free, but here more and more free. Freezing. Yes, freezing. Yeah. Of course, to change solid state to liquid one, you need this to be more free, right? To move more, to change these properties to this, right? Yeah. So when you heat the solid, yeah, yes, by heating the solid, the force between them decreases, right? So become more free, more space is change from solid to liquid. Okay? So change from solid to liquid. How? By heating. And this process is called what? Melting. So, for example, if you have ice cream, in the hot days, of course, you can see that part of it melt on your hand, right? Parts of it melt on your hand. So here, what inside by heating, change from solid to liquid. This is called melting process. If you heat some amount of water, to change of what? From liquid state and change it to be vapor states, which is water vapor, of course. By increasing the heat, the movement of the molecules increases. the movement increase, spaces increase, more free away from each other, so change it to gas state. Okay? The opposite process for melting, for evaporation, or changing to vapor, you have to return it back again. Yes? You reach from solid to liquid with heating, right? So the opposite is cooling. If you have a small amount of water and you need to change it to ice, what will happen? What you will do? You put it where? On the flame? Of course not. You will not heat it, of course. You what? Of course in the freezer, right? You cool it. By cooling liquid, it change into solid. Return it back again to solid. So this is melting from solid to liquid, but from liquid to solid is what? Yes? Is freezing. Yes, you use a freezer. So freezing, by cooling it, get closer to each other, more strong, attract each other. Understand? Yes? The same for it. Heating the liquid state or water, the water changed by heating it to liquid, to vapor state, gaseous state. By cooling, the water vapor collect it, for example, on a cold surface like the mirror, the bathroom, for example, on the wall. It changes from the from the vapor or gas state and return back again to liquid, like condensation of water vapor forming clouds in the sky. As you know, this is called condensation. So you have melting from solid to liquid, from liquid to solid is freezing, from liquid to gas is what? Evaporation, right? Yes, and from gas to liquid again is what? Condensation. Is condensation. Okay? So freezing, like water to be ice, is a freezer, change from liquid to solid. Okay? Yes, ice to melt, need heat of course, from solid to liquid. This is a melting process, speed increase and so on. Evaporation process, liquid change to gases, as you know. Heat the liquid water, change it to water vapor by changing the movement or speed up its movement, yes? Water change it to water vapor. Condensation, yes, when water vapor condenses or collected on a surface, which is cold surface of course, collected again, return it to liquid water again, yes? Gas into liquid water. Okay, clouds formed as we said. Thank you.